Okay, these are vertically moving systems. Vertically moving systems they're strange. I guess you just need to remember one thing. Just remember that gravity is minus 10 meters per second squared. We'll use minus 10. If you remember that fact, then you just logic your way through all this stuff. So it says here, a fish hangs from a spring scale supported from the roof of an elevator. Okay, so let's draw ourselves our fish. There, and it's hanging from this elevator. And let's see here, if an elevator has an upward acceleration of 1.2 meters per second squared, the scale reads 200 newtons, what's the true force of gravity on the fish? So remember, this whole thing is moving upwards at 1.2 meters per second squared. That's what they tell you. But you got to remember that gravity is already acting at minus 10. So actually, for this thing to be moving upward at at 1.2, it's got to overcome this 10. So you're actually going to be accelerating at 11.2 meters per second squared. Okay, so at that 11.2, you're reading 200 newtons. So let's go F equals ma. What's the force? 200 newtons. We don't know the true mass of the fish, so we'll find that. We'll accelerate at 11.2 meters per second squared. Solve that for m, and now you know that you have a mass, 17.85 kilograms. It's a pretty big fish. But that fish is accelerating upwards now. Now we know the mass. Now we can find the true force of gravity by taking the mass and just going F equals ma. Or Fg equals m gravity. True force, 17.85. Use gravity as 10. So your force due to gravity is 178.5 newtons. There you go. The answers are on here based on 9.8, so 178, and we have 178.5. They'll change slightly because of the 9.8 versus 10. So that was A. B would like us to answer, under what circumstances would the scale read 150 newtons? Well, for that one, we just go Fg equals mass times gravity. Force due to gravity is our scale reading of 150. We know our mass is 17.85 kilograms. Solve that for the acceleration. That's required. I guess this should be A, not gravity. F equals m A. Whatever. Okay, solve that thing out for your acceleration. You get acceleration being 8.4 meters per second squared. Well, 8.4 is not this 10 that we already have. So we need to figure out exactly what that's going to be as an acceleration. So I'm going to go here, 8.4, subtract it off of our 10 that we already know, and you're going to get an acceleration being minus 1.59 meters per second squared. That means that instead of the elevator going up, you're actually going downward. Okay, so you're actually going down, so it should be reading a little bit less than the actual true 178 newtons. It's reading 150 because it's falling. And for part C would like to know, when will the scale read, or what will the scale read if the elevator cable breaks? Well, cable breaks, then your fish falls at the same rate. So fish falls at the same rate as the elevator. And if you're tied to the top of an elevator that's falling and you're falling, in the end you're going to read 0 newtons, which is what happens to that fish. No reading. Okay, so there's vertically moving systems.